ViSE is sort of a culmination of something that's been going on at Vanderbilt for a number of years.
Largely it's been innovative surgeons kind of looking for new ways to treat their patient, and then engineers, we love problems, or problem solvers, that's what we do. So putting us together has always made sense.
Over the last 25 to 30 years, this has built into about a $20 million enterprise.
We've all been working at this interface between engineering and medicine, and more specifically in the area of surgery. We had an informal network of collaborations, but there was no real formal structure.
Everybody kind of put their heads together and said, maybe we should make this a little bit more formalized, and maybe by doing that, we'd be able to achieve more, we'd be able to publicize that, we'd be able to attract better students, attract better faculty, and do more to help surgeons treat the disease.
That's the time at which ViSE, which stands for the Vanderbilt Initiative in Surgery and Engineering, was created. The two main purposes are first to formalize the type of interaction that we have between engineering and medicine. It also has increased the visibility of the effort at the institutional level tremendously.
The fact that our surgeons are able to be in the engineering labs in a few moments to look at new prototypes and new ideas, I think is probably one of our greatest advantages.
We send all our students in the OR. All devices move into the OR so we can actually get data.
We create microstereotactic frames which are customized for an individual patient based on that patient's anatomy and where those markers are placed. This is produced real time while we're in the operating room, and then it's rushed down to the OR and sterilized. There's a steering committee, and that steering committee tries to find ways to help collaborations grow.
We needed something that brought us together on a kind of regular basis. So the seminar series has acted in that way. We've had engineers and surgeons come together that never met each other, and from that seminar have started to talk and actually create proposals together.
It's good for everyone, good for the faculty, because sometimes you have physicians coming to those meetings that we had, or to those presentations that we never had before. It's good for the students because they really start to know each other across departmental boundaries.
We don't know what the future holds, but this allows us to react rather quickly. We can have idea sessions where we have surgeons and engineers together. We can postulate crazy ideas. We can distill everything out down to things that are actually achievable. We can then build those devices. We can test them in the laboratories. We can go through the regulatory process and take them to the clinic, take them to the operating room, and see what the effect is on the patients.
It's a great feeling to know that the technologies that you're working on have the potential to benefit patients.
I think all of us are constantly wowed by technology, and surgeons are the same way. One of the things that falls to us, though, is to be really involved in the creation of technology and in its assessment, because in the end we have to be sure that the technology is worthwhile, not only from a patient standpoint, but also how it impacts our healthcare system.